To understand how a computer functions and how information is stored within it, you need to know a thing or two about number systems. What is a number system? A number system, simply put, is a way of representing numbers. All number systems have a base which define what symbols, including zeros, can be used to represent values. For example, the decimal number system that you are most familiar with has a base of 10, which defines the symbols that can be used, 0 through 9. The decimal number system is the one you're most familiar with, but it's not the only number system that you need to know. Number systems represent numbers by combining symbols and what is called positional notation. You normally think of this as place value, that the value of each symbol is derived from its position or place. Remember when you were a kid and they taught you ones, tens, hundreds, thousands, and so forth? Well, they were actually teaching you positional notation all along. The idea of positional notation helps us determine the place value of a particular symbol. All we do is take the base of the number system, for example 10 for decimal, and raise it to its position, starting with 0. This explains why the first place value in the decimal number system is the ones place, because 10 to the 0 is 1, and why the second place is 10, because 10 to the 1 is 10. Whether they taught it to you this way or not, this is how actual place values are determined. Let's take a look at some of the more common number systems. Decimal is a base 10 number system which uses the symbols 0 through 9 to represent values. Anything to the right of the dot or decimal is considered to be a fractional part of the number. Binary is a base 2 number system which only uses the symbols 0 and 1 to represent values. Each 1 or 0 is referred to as a bit or a binary digit. It turns out that binary is the number system that computers like because a transistor can only assume one of two states, on, 1, or off, 0. Since binary as a number system only contains two symbols, it can be used to perfectly match the state of a computer's transistors. I have a great video here from Pumpkin Programmer that will get you working with and confident in binary in no time. As always, make sure you can answer the essential questions before you move on. It's important to note that a single bit, a single binary digit, cannot be used to represent anything of any real value. When we string bits together into a sequence of ones and zeros, then we can represent almost anything within a computer. So let's talk about binary. Binary follows the same number system rules and positional notation rules that we talked about. The place value for the first symbol is 2 to the 0, or 1. The place value for the second place is 2 to the 1, or 2. The place value for the third place is 2 to the 2, or 4, and the pattern continues on towards infinity. To figure out the number that this sequence of bits represents, all I have to do is sum up the place values for the bits that are on, and I get the number I'm representing. In this case, I would add 8 plus 2 plus 1, and that gives me the number 11. In reality, what really happens is we take the symbol and we multiply it by the place value, and then we sum up the results of those operations to get 11. You probably heard the term byte before. The term byte refers to a sequence of 8 bits or binary digits, 8 ones and zeros strung together. Byte is short for binary term. Now there are a lot of great apps out there that can help you learn and master binary. I would recommend Binary Practice if you are on an Android app, and Cisco Binary Game if you have an iOS device. Another number system that's worthy of note is called hexadecimal. And this is commonly used by programmers to represent things like memory locations and colors. Hexadecimal is a base 16 number system. And as you can see here, they run out of numerical symbols to represent values, and so they have to start using letters like A, B, C, D, E, and F. A is 10, B is 11, C is 12, so forth and so on. It's important to understand that I can use one or more number systems to represent the same value. Here I show you how you can represent the number 21 in decimal, binary, and hexadecimal, respectively. Let's recap the big idea. Binary is a system that's perfect for computers because it can match perfectly the two states a transistor can assume, 1 for on, 0 for off. A binary digit or bit by itself can't represent much of anything, but when you sequence bits together, you can represent almost anything within a computer.